Section 7.5, Applications with Rational Equations. So we're going to need to set up an equation that's rational, which means we're going to have some fractions. And then we'll solve it just like we did in the previous section. Number 1. Jason can wash and wax his car in 4 hours. His younger sister can wash and wax the same car in 6 hours. Working together, how fast can they wash and wax the car? Well, logically, it should be less than 4 hours. And the reason why is because if Jason can do it alone in 4 hours, why would he want his sister helping him if it takes him longer? So working together should be less than 4 hours. So we have to work with a proportion because Jason and his younger sister are not getting the same amount of stuff done in a 1 hour time period. So if Jason can wash and wax his car in 4 hours, he gets 1/4 done in 1 hour time period. If his younger sister can wash and wax in 6 hours, she gets 1/6 done. And now we're looking to see how fast can they wash and wax the car together. So, first things first, we need to ask what is the question wanting us to find. It wants us to find how fast can they wash and wax the car. So x is going to equal the time together. Now our equation is going to be set up as 1 over the time of the first person plus 1 over the time of the second person should equal 1 over the time together. I call these the 1 over, 1 over, 1 over. It's always 1 over, 1 over, 1 over. Don't worry if it's an hour or a minute or a day. You set these up the same exact way. So now we just got to plug in for what we know. We know that Jason can wash the wax in his car in 4 hours. So the time of one person is 4. So we have 1/4. Plus, the younger sister can wash and wax it in 6 hours. So the second person's time is 6. So we end up with 1 over 6. And we're looking for the time together. So we're going to have x in the denominator. So 1 over x. Looks very similar to the problems from the previous section. Now we need to find an LCD, multiply every term by it to get rid of fractions. Our LCD between a 4, a 6, and an x would be a 12x. So we'll multiply everything by 12x over 1, and hopefully that will cancel out the fractions. So 12x times 1, but divided by 4, is 3x. 12x times 1, but divided by 6, is 2x. And 12x times 1, but divided by x, is just 12. Combining like terms, we get 5x equaling 12. Divide by 5 on both sides, so x is going to equal 2 and 2/5. I like to keep it as a fraction. If you want to change it into a decimal, you can. So what does that mean? Together, it's going to take them 2 and 2/5 hours to wash and wax the car. So together, it takes 2 and 2/5 hours. Which makes sense. It's less than 4, which is how fast Jason could do it alone. So it definitely needs to be smaller than that. Number 2. Working together, Rita and Tiffany can cut and trim a lawn in 2 hours. If it takes Rita 5 hours to do the lawn by herself, how long would it take Tiffany to do the lawn by herself? Again, what is the question asking? How long will it take Tiffany by herself? So x is going to equal Tiffany's time. We're going to set it up the same exact way. 1 over the first person's time. Well, it does take Rita 5 hours, so we'll let her be the first, so 1 over 5, plus Tiffany's time. We don't know Tiffany's time, so that's going to be 1 over x. Equals the time together. Well, it says Rita and Tiffany can cut and trim the lawn in 2 hours. So together it's 2. So it'd be 1 over 2. So we have 1 over 5 plus 1 over x equals 1 over 2. So now we need to find the LCD. The first number 5x and 2 can all go into is 10x. So I'll multiply everything by 10x over 1. When you do so, we end up with 2x plus 10 equaling 5x. I'll let you finish that. You should end up with x equaling 3 and 1/3. So what does that mean? It takes Tiffany 3 and 1/3 hour to mow the lawn by herself. Number 3. The cargo hold of a ship has 2 loading pipes. Used together, the two pipes can fill the cargo hold in 6 hours. If the larger pipe alone can fill the hold in 8 hours, how many hours would it take the smaller pipe to fill? So we'll set it up the same way. 1 over, let's do the large pipe, the time of the large pipe, plus 1 over the small pipe is going to equal 1 over the time together. So what are we looking for? It says how many hours would it take the smaller pipe? So we don't know the smaller pipe, so x is going to be the time of the smaller. Now let's fill in for what we know. Do we know the larger pipe? Well, it says that the larger pipe can fill it in 8 hours, so its time is 8, so 1 over 8, plus the smaller pipe, we don't know, we called it x, so 1 over x, equals 1 over the time together. How long does it take them to work together? We'll use together, the two pipes can fill the hold in 6 hours, so 1 over 6. Same process, we find the LCD, multiply return by it. So the first number 8, x, and 6 can all go into is 24x, so I'll multiply everything by 24x over 1. When you do so, you'll actually end up with x equaling 24. So it takes a smaller pipe takes 24 hours to fill the hold on its own. So really the setup is just 1 over, 1 over, 1 over. The one that you have to really be careful about is the time together. That should be on the other side of the equal sign. And then put the other ones wherever you like. Number 4. Sailing in opposite directions, an aircraft carrier and a destroyer leave their base in Hawaii at 5 a.m. If the destroyer sails at 30 miles per hour and the aircraft carrier sails at 20 miles per hour, at what time will the two ships be 300 miles apart? So these are different problems. So let's figure out a picture that'll help us create an equation. So the good thing about this is they're both leaving at the same time. They're both leaving the base in Hawaii at 5 o'clock. So there's my Hawaii, and they're both going to leave at 5 a.m. The destroyer sails at 30 miles per hour and the aircraft carrier sails at 20 miles per hour, but they are going in opposite directions. So from here, we'll say that that direction will be for the destroyer, and the other direction will be for the aircraft carrier. So now we have to know how are distance, rate, and time all related. Well, distance is going to equal rate times time. So let's go ahead and write the distance for the destroyer and the distance for the aircraft carrier. So the distance for the destroyer, d, is going to equal its rate times its time. Well, its rate is 30 miles per hour, and its time we don't know, so we'll call it t. So we'll have 30t. The aircraft carrier distance is equal to its rate times its time. Its rate is 20 miles per hour, and its time we don't know either. We can actually use the same t for time because they both started at 5 a.m. so we don't have to worry about changing the time. The last piece of information says at what time, that's what we're looking for, will the ships be 300 miles apart. So when they get to be 300 miles apart, we want to know what's the time. So if we add the distance of the destroyer plus the distance of the aircraft carrier, we should get the total distance, which is 300. So we'll have 30t plus 20t is going to equal 300. The distance of one plus the distance of the other should equal the total distance they're going to be apart. Putting those two together, we get 50t equaling 300. We'll divide by 50, so t is going to equal 6. What does that mean? It will take them 6 hours to be 300 miles apart. On number 4, it said at what time. So since it takes 6 hours to be 300 miles apart, the time is actually at 11 a.m. I'll accept either answer, but it did say at what time, so we need to make sure that we say 11 o'clock. So number 5. A ship leaves a port traveling at 15 miles per hour. 2 hours later, a speedboat leaves the same port traveling at 40 miles per hour. How long will it take for the speedboat to overtake the ship? So this is a little bit different than the previous problem because they did not leave at the same time. They're also not going in different directions. They're going in the same direction. We have a ship that leaves, so there goes the ship. And then 2 hours later, a speedboat leaves. So here's the speedboat. And we actually want to know, when does the speedboat, in a sense, overtake the ship, so catch up to the ship? We're still going to use a formula, distance equals rate times time. So what is the distance of the ship? Well, the distance of the ship should be its rate times its time. So 15 miles per hour, there's the rate. Time we don't know, so we'll call it t. So its distance is 15t. Looking at the speedboat, what is its distance? Well, its distance is its rate times its time. Its rate is 40 miles per hour times its time. Now, it left 2 hours later, so it had a 2-hour delay, so its time has to be t minus 2. If you want to use a ship having a 2-hour head start, you would have 15 parentheses t plus 2. And then the speedboat would just be d equaling 40t. So it depends on how you look at it. I look at it as the speedboat has a 2-hour delay, so its time has to be t minus 2. Now, we want to know how long will it take for the speedboat to overtake the ship. So what that means is, when are the distances going to be equal? When does the speedboat overtake the ship? So the distances have to be equal. So 15t is the distance of the ship, and it's supposed to equal 40 times t minus 2, because that's the distance of the speedboat. Distributing in your 40 and solving for t, you get t equaling 3 1/5 hours. The problem is that is not our final answer. If you notice, the t that I found went with the ship. The time that the ship went was 3 1/5 hours. However, we want to know how long will it take the speedboat to overtake the ship. Its time was t minus 2, so I need to subtract 2 from that, and I end up with 1 1/5. So it takes the speedboat 1 1/5 hours to overtake the ship. So make sure whatever variable you're using goes with what the question is asking. Number 6. A river has a current of 3 miles per hour. A boat goes 40 miles upstream in the same time as it can go 50 miles downstream. Find the speed of the boat in still water. Okay, so this is another kind of different problem. We are going to look at distance equaling rate times time, but we're going to get time by itself because this problem said in the same time. So let's go ahead and figure out how to set this up. I like to draw a table. And the table is going to look like this. Your formula is distance divided by rate equals time. Why did I set it up that way? Because it did say in the same time, so I know the times are going to have to be equal. The time upstream will have to equal the time downstream. So we have an upstream row and we have a downstream row. Let's go ahead and start filling in the upstream. Do I know the distance upstream? Well, the boat can go 40 miles upstream, so we know the distance upstream is 40. In the same amount of time it takes to go 50 miles downstream, so the distance is 50. Now the rate is the thing that always causes a little bit of difficulty, because you have to understand that if you're in a river and you turn your motor off, the boat does not just sit there, it goes downstream. So the rate is actually the rate of the boat, and then plus or minus the rate of the current. Now why is that? Because the current is either going to help you go downstream or it's going to slow you going upstream. So which one goes with which? Well, upstream has to be a minus because it's going to slow you down. Downstream has to be the plus one because it's going to help you go faster. So you need either the rate of the boat or the rate of the current. So reading what the problem says, it says a river has a current of 3 miles per hour. So we know the current is 3. And it said find the speed of the boat, so the speed of the boat has to be the x. So the x is going to go first. It does not always go first. It depends on, do you know the rate of the boat or do you know the rate of the current? So downstream is going to be the x plus 3. Upstream will be the x minus 3. Again, just make sure you understand what the rate's doing. You take the rate of the boat plus or minus the rate of the current. The boat we don't know, so we called it x. We do know the rate of the current. Upstream slows you down, so it's the minus. Downstream helps you go faster with the current, so it's a plus. Now, what do we do with that column for time? Well, it's distance divided by rate. So the distance divided by the rate. So 40 divided by x minus 3 is the time upstream. 50 divided by x plus 3 is the time downstream. And what's true about the times? The times have to be the same, so they have to be equal. So 40 divided by x minus 3 has to equal 50 divided by x plus 3. Now that we have our equation, we need to find our LCD and multiply every term by it. Our LCD would be x minus 3 times x plus 3, again all over 1. So when I multiply by the LCD, the x minus 3's are going to cancel, so I'll be left with 40 times the x plus 3. On the other side, the x plus 3's will cancel, so I'll be left with the 50 times the x minus 3. I'll go ahead and distribute the 40 and distribute the 50 and continue with this problem. So we're going to end up with 40x plus 120 equaling 50x minus 150. I'll bring the 40x over to the right, the negative 150 over to the left, and I'll end up with 270 equaling 10x. Divide by 10 on both sides, so that tells me x equals 27. So what was that? The x represented the rate of the boat. So the boat is going 27 miles per hour.